very good. So, well, if you guys want me to, I can put something in pink. And so the way that this happens, it's generally acid catalyzed, so we need a little bit of acid here. Anyone want to take a guess? Like, what are the first kinds of things? What do we want to do here? Okay, let's break the double bond. And okay, let's put the H to the O like this. Okay. Where does the other part of this small molecule of the alcohol go? To the carbon? Oh, to this carbon? No. Sammy says no. Okay. Let me put it to the correct carbon. Oh no, did I erase some carbons here? Okay, so this is absolutely correct. Now it's just trying to draw it correctly, right? Okay. So I'm going to say OH, and this H that's here, that's the pink H from the alcohol. And then what am I missing here? Yeah, I have this OCH2, CH3 bis. If you guys need me to number my carbons, let me go ahead and do that if that helps you visualize.
So it stays on the same carbon, what you're adding.
You mean?
So it was a double bond, but then you broke it up and now.
Correct.
You know what I mean? Like you went off the same carbon. So off carbon 2, you added the H and OCH2, CH3.
I added the H to the oxygen.
Mm-hmm.
So the H went to the oxygen.
And then on the same carbon.
On carbon number 2, I put this part. And so now what we have is a hemiacetal. Shall we do another one?
Yes.
Okay. Okay. What bond do you want broken? Okay. Anything else?
And the bond between the
Okay.
and we'll redraw them.
You want me to redraw it?
Well, I mean, like for the product. So then you add an H to the O.
Okay. I add an H to the O.
So then you just branch off from the same carbon and just put the OCH3.
That's it. That's it.
So if there was a line structure, like there was on the exam line structure, you could still write it out like that?
Oh, absolutely. Yeah, I'm fine with that. Are you guys getting more comfortable with this? Yeah? Okay, great. Good. And then, I mean, so I mentioned that these reactions, you know, this hemiacetal is extremely reactive. And so what we can talk about, I don't want to talk about it right now, but hemiacetal can undergo another reaction with more alcohol. As long as there's alcohol that is hanging out around the area, you end up forming an acetal. And so an acetal, the generalized structure of an acetal is right here. And what's different than the hemiacetal is that the acetal has like two ethers that are attached to the same carbon. Exactly. So instead of the alcohol, you have two of the same ethers attached to the same carbon. And the reason why this happens, like, you know, in the lab, you can't just go and make a hemiacetal. It doesn't work that way. They're way too reactive. They will react with more of the alcohol solvent and generate an acetal, which is okay. Acetals are wonderful. They're great protecting groups. You'll find, and I will do examples on Wednesday regarding this. But we are going to talk more about formation of a hemiacetal, or more forming the acetal on Wednesday. So if you guys need whatever you need, coffee, something, like if you need a run, like a quick half mile before you get here, or
I need my son to have a good night's sleep.
I understand that. Yeah, I get it. So I will see you guys on Wednesday, and we will finish up at least this part of the chapter on Wednesday. So you guys have a great day, and I will see you all then.